Right. Well, this is one of the subjects that's becoming being on repeat as an area of concern, but also an area of hope and excitement. It is, of course, artificial intelligence. And there are lots of conversations going on around this point about the limits and the realities of AI. I mean, what is AI actually capable of at the moment? It is a big talking point right across the world. So that's why we've decided here at the Singapore FinTech Festival this week to curate a number of sessions on this. A session coming up shortly will discuss artificial intelligence, especially with so much being said about it. We talk about it in so many contexts, don't we? From self-driving cars all the way through to the way that we interact with our banking apps, for example, or our bank. One must also wonder how much of all of this development in AI can actually be put to practical use. So in order to talk about quite a complicated subject, something that reaches far into the future, you need a very highly esteemed panel. So Malavika Raghavan, who is advisor and former head of future finance initiative at Dvara Research, will moderate a panel of experts, and this is exactly what they'll be discussing. She will be joined by Kfir Godrich, who is BlackRock's global head of technology, Dawn Song, who is founder and chief executive officer of Oasis Labs, and Dr. Michael Zeller, head of AI strategy and solution at Temasek, and Wenyuan, who is the founder and CEO of Paradigm. Well, hopefully they are all standing by live, and we can cross over to Malavika and the panel to discuss the merits, the limits, and the realities of using artificial intelligence.
Thank you so much, and it's a pleasure to be here. My name is Malavika Raghavan, and I'm a lawyer and independent researcher in India, focused on policy and regulatory issues at the intersection of technology and financial inclusion. And as someone who cares about inclusion and also closely observes the fintech ecosystem across Asia, I think one of the big promises for finance and inclusion and the growing of the depth of the financial markets has really been artificial intelligence and its deployment in the financial sector. So to cut through all that hype and to focus on brass tacks, we have an excellent panel with us who I will shortly hand over to introduce themselves. In terms of format, for the next 40 minutes that we have you, we'll spend about 20 to 25 minutes discussing some of these issues. We'll have 10 minutes for audience questions, and then we'll move straight into the closing of the session. So with no further ado, I'll first invite Professor Song to introduce herself, and I'll ask all the panelists to just answer this one question as you introduce yourselves, is that in your work with AI, what is the one thing that most excites you and one thing that most worries you? So over to you, Dawn.
Great, thanks a lot, Malavika. And thanks a lot for having me here. My name is Dawn Song. I'm a professor in computer science at UC Berkeley, and also the founder of a startup called Oasis Labs. And my work focuses in AI, machine learning, and also security and privacy. So in my work, and also I think in the space of AI in general, one of the things that excites me the most is program synthesis. So now we have seen that AI and deep learning can really do a lot of things. They can help us translate from one language to another. They can play Go better than humans, and they can play now sophisticated video games as well. But one thing that really excites me is how computers actually can learn to code, to learn to program, and that's what's called the program synthesis. And with this capability, it can really help a lot of people. A lot of people, they have great ideas, but they don't actually know how to write code. So for example, one of the examples of program synthesis and how that can help everyday users is using program synthesis, we can automatically translate natural language description into simple code, for example, into database queries to help everyday users to be able to do data analysis without actually being able to write code. So, and in the future, of course, we hope that computers can learn to write even more sophisticated code. So what worries me is really about security and privacy issues in AI and machine learning. Even though deep learning has been making great advancements, But however, from my research and also other researchers' work, we have shown that these models are really vulnerable. They are very easily fooled by attacks. And also there are lots of privacy issues as well. Our work also showed that these machine learning models, by just creating these machine learning models, attackers can actually learn very sensitive information in the original training data. And as we deploy machine learning systems more prevalently, security and privacy issues definitely, I think, some of the most worrisome challenges and the most important challenges that we need to address.
Thanks, Don. My name is Michael Zeller. I'm the head of strategy and solutions at Temasek International. And as you may know, Temasek is an investment company headquartered in Singapore. We are a global investor with a net portfolio value of over 200 billion US dollars. So a very vast spectrum of sectors that we cover with our portfolio, including financial services, telecommunications, media, transportation, industrials, consumer real estate, life sciences, agribusiness, energy, resources. And so in my role, I look inward, helping the organization adopt AI across our functions, as well as outward, working really with our portfolio companies on adopting AI. And what excites me the most about AI today is, looking back as a researcher, as a grad student, it was very difficult to deploy and to utilize AI. And then machine learning now is applied everywhere. It's become mainstream. And working at Temasek with a vast portfolio across virtually all sectors, I feel like a little bit like a kid in a candy store. From finance to healthcare to manufacturing to energy, there's so many hard problems to solve, and it's fantastic to be kind of working in that environment. But also to apply AI for good causes, to look at sustainability, for example, which is at the core of everything that we do in terms of our investments. So really helping us work on AI, working on very hard, challenging problems, but really also looking at making an impact with that technology on future generations. Now, what worries me the most about AI is really a little bit the hype cycle that we're in, that we're overhype its capabilities, and that we everybody says in presentations right now that they are using AI, but very few are truly using AI. So I think we need to be careful that we balance the overhype with what the realities are, and that we manage also the fear of the technology so that doesn't hold us back. So manage, as Dawn said, privacy concerns on data. And with every technology, we need to manage that risk very carefully. So I believe the best is still ahead of us, and it's an exciting time to be working in that field. So with that, Wenyuan, over to you.
Thanks. Yeah, I'm Wenyuan, founder of the Chinese AI startup company, the Force Paradigm. I started the company, the Force Paradigm, in 2015, 6 years so far. Our vision is AI for everyone, because we want to help every company, every business, every scenario based on our AI technology. Half of our business is in finance. The key customers include very large banks in China, for example, ICBC, CCB, CMB, and hundreds of other banks, insurance, security in China. We have also customers outside China, for example, HSBC. I think the most exciting AI is its value to the industry. I used to work for one of the largest internet company, Baidu, and help them improve 800% of its revenue by AI. Now we are applying similar technology to finance, and so far we have seen great improvement in finance. Maybe I can show some case later. And the most challenging is how to let people understand AI, understand what AI can do and what AI cannot do. Most people think AI is face recognition, speech recognition, or self-driving car, but they are usually not relevant to their business. We should let people know how AI can help their own business. For example, for a bank, we should let people know how AI can help us do better risk management, better marketing, and better regulation. AI is not new, but AI for business is a new topic. We are now spending a lot of work to educate the marketing, and we hope in 5 years, most business people will understand how to use AI to improve their own business. Thank you.
Hello, everybody. My name is Kfir Godrich. I am Global Head of Technology for BlackRock. BlackRock is an asset manager focused on the right retirement of people around the world. And we are focused on that purpose. When it comes to what I'm doing at BlackRock, I'm covering technology, data, and AI, supporting our Aladdin fintech platform, and enterprise services and information security. What excites me most about AI is working with a group of smart people to use machines in order to replicate human intelligence, in order to solve high-impact business problems. Applied AI, taking math through machine learning, and sometimes getting into real AI. This process of ideation to production, it's what drives me in that journey. What worries me is biased, irresponsible, and uncontrollable AI. And maybe a little bit this new idea of client as a machine, as a direction of the world right now, it's another area that needs more thinking. So back to you, Mala.
No, I'm glad you said that, Kfir, because in my work, they say the consumer is often the product, which I think is a pretty scary world to be. But before we get there, actually, I think to kick off the kind of substantive discussions, I want to just come to Wenyuan first and talk about the practicalities, because as you've all mentioned, the hype cycle has kind of been there and done that with AI. So practically, for all the people listening in who may be considering an AI solution that they're going to buy for their financial institution or for regulators, Wenyuan, can you tell us some of the key ways that your business is serving financial institutions? Because I understand you have some pretty big success stories, especially on customer marketing and fraud detection.
Let me start from the fundamental methodology for AI to help business. The methodology is to find underlying patterns from the big data and generate rules to better run business. Let me use fraud detection as a case. In before, there are a lot of domain experts in every financial institution. Their work is to summarize the domain knowledge based on their experience. The domain knowledge may contain several hundreds of rules because people will type, so people cannot find so many rules. Maybe 100 or 1,000 rules is large enough for people, but computer can find more because computer will not tired. We help one bank, for example, we help one bank to find billions of rows from data to detect fraud behavior and improve 700% in accuracy. And for marketing, we use the same methodology. We are also finding billions of rows every day from the marketing data, and help the financial institution to do better marketing and greatly improve their revenue. So the fundamental methodology is to use AI to find the domain patterns from the data and find much more roles than the domain experts.
And I want to come back to that actually when we talk about the accuracy of those rules, because I think that's probably a big talking point. But before that, I mean, I think obviously it's very clear on the consumer side in terms of marketing and fraud detection. Those are very clear use cases. But Kfir, if I can come to you more in terms of investments in the financial markets, right? And especially given the turbulence or in certain markets over the last few months as well, how has your role changed, or has anything changed? And also kind of where are you using AI in your internal processes at BlackRock?
So, you know, for us, for what we're doing, certainly risk is a very important area of our practice. And some of the first use cases that we started utilizing machine learning and AI was in the area of operational risk that we are tracking in our environment and for our clients. And we developed a bunch of very sophisticated tools originally that we kind of took a monthly look into them with our op risk colleagues. As pandemic hit around March in the US, we started moving all this know-how to a daily basis view, such that we can have a more updated and more synchronized to reality view with our capabilities of MLAI there. But we started all that journey with the area of anomaly detection and early warning. Basically, quality control for our data factory was something that we always wanted to get, and we were almost interested to get it better and better. So if you're thinking about the mission of even pricing every day 500,000 securities around the world in dynamic markets, very fast you're getting to billions and billions of points of data. So how do you minimize mistake in your data factory? What you're doing there is developing some smart algorithms of AI to deal with that. But the next question will be, how do you integrate that? How do you integrate that into what you have already? And the integration in that production, if it's not efficient, you are not going to be successful. The idea is to augment human capabilities. And therefore, the natural way of doing that is to run two parallel paths. One will be the human path, and the other, a continuously feedback parallel system that you're going to learn and converge them in the most natural way, which is always in central monitoring, such that all the information can come in an unbiased mode in front of the operator. At the end of the day, with all this AI, we are trying to augment human capabilities. There is no way that we're going to replace human in that process. So therefore, we are very much focused on that intersection of human and machines for optimal outcomes in our view here.
So there are a couple of things that you said that I want to pick up on. One is, of course, this kind of large-scale, hyper-fast decision-making and pattern recognition, which came up in Wenyuan's comments. But also this on the point of operational sort of deployment, right? And before we go into the technical side, maybe I'll just bring Michael in here because I think, Michael, one of the things you're doing is actually seeing that operational deployment happen across hundreds of companies in your portfolio. And can you tell us maybe this specific point that I'm very interested in on the kind of, integration and the handoffs between AI and people in your firm who ultimately are serving, the real economy. How do you see that playing out?
Yeah, certainly. I think this is an important topic, kind of the interplay between humans and machines to make us more effective, to make us more efficient. But if I look at really a vast portfolio of different industries and companies, the adoption of AI is very, very different. There are, some that are more advanced, like Kfir's company, probably similar to that in the financial industry. They're okay, really leveraging AI and deploying models, but many, if not most, are struggling with AI. And if I look at the biggest challenges remains operational deployment. And too often it's kind of an afterthought, and too often data science remains in the science aspect and is not integrated and deployed into our existing IT environment because people don't appreciate the challenges that it takes really to make it available to utilize AI in real time, to integrate it with the right data sources. When you have to make those decisions, either to hand it off to a human to bring it to attention in the terms of fraud detection, kind of create a top 10 list of cases to go after. We have more and more data, more and more integration, but with more data, the last thing we really need is more reports, more dashboards. What we really need is a fully automated, integrated system. And only then we can really, I think, capture the ROI of machine learning. That's where, if the models start ticking in our infrastructure 24/7, ideally in real time, that's when we, I think, see the biggest payoff. But that planning really requires to understand the complexity. To look at what platforms do we really need? How do we integrate it? What are open standards that we can leverage, independent of the algorithm type that happens to be the most favored today? I mean, model complexity, for example, has improved dramatically over the last decade, with deep learning now kind of being the most favorable model type in many cases. And then also deployed independent of single vendor solutions. This is still a very highly fragmented market. Lots of solutions, lots of really good solutions out there. But as a large organization, I need to be able to pick and choose and combine multiple solutions. And so looking at kind of open standards and open platform is very, very critical. And then if you mature in your leverage of AI, what happens if you move from just a few models to hundreds of models? So you need to also look a little bit ahead of the curve and say, if I have one model in production today, what happens if I have 10, 50, 100? What happens to my governance around deployment? What models actually get deployed in production? Who decides when to deploy and what gets deployed? Do I have a correct audit trail around deployment and decisions made by the models? Really, models and data are intertwined. So we heard that earlier that we have privacy issues. So am I using the right data to build the model, the right data to make decisions? Otherwise, I may have regulatory issues. So I think this is kind of a long-winded answer to your question, that the largest challenges in the operational deployment, yet we need to make sure that we really solve that as a fundamental question for all our infrastructure solutions, so that we can have not just one model and one IT project deployed at a time, but that we look at this as a platform approach, similar to many other IT solutions that we built in the past.
And I mean, to pick up on this operational complexity point that you raised, Michael, and also I think two things have come up where I'd like to bring Professor Song in. One is, of course, data, like the increased availability of data. When we talk about stacks, I wonder about haystacks, right? Because you create all this data and also multiple types of decision engines running simultaneously, often in different organizations. What are some of the technical challenges, Professor Song? I think privacy has already come up, but when you're dealing with such complex models, what are some of the challenges that you see, not just in the model itself, but then as its impacts play out, how do you deal with that? And what are your views given where you sit?
Yeah, that's a very good question. So of course, I mean, there are really many challenges, and some of those, like Michael has mentioned. And one of the things, as I mentioned, really is, I think some of the other panelists also mentioned, like these models, they are complex, and we really don't know actually what these models are doing. And so we don't have good explainability. We don't really have any guarantees of how the models will actually behave under rare conditions, previously unseen conditions, and so on. And right, so these models are now robust, and they are very easily attacked. So just to give you some examples, in some of our earlier work, we showed that, for example, in the self-driving car situation, you want to have a computer vision system to be able to recognize, observe the environment, for example, recognize traffic signs and so on. And we show that you can actually, attackers can actually manipulate the traffic signs in some very minor ways, and in ways that humans will still actually be able to recognize these traffic signs with no problem. But the computer vision system can be completely fooled to give the wrong classification of the traffic sign. And this is just one example. And actually, so interestingly, our artifacts, these traffic signs with the manipulations, they actually have been on exhibits at the Science Museum in London, showing, educating the general population about the challenges actually in these machine learning models today. And that's just one of many examples. Our work also showed that with machine translation, for example, they are doing amazingly well today in general. But however, our recent work showed that one, for these cloud machine translation services, first of all, it's actually very easy to steal the models that these Google, Microsoft, these big tech companies have spent lots and lots of money to train. But actually, just by simply querying these models through these cloud APIs, one can actually build, we call it an imitation model with very close accuracies. And then once we build this imitation model, we can actually generate attacks using this imitation model, essentially generating texts with we call it adversarial examples that actually can cause these machine learning, the machine translation models to actually give wrong translation in a very targeted way. And also we show that these attacks that we generate using these imitation models can actually be effective with high likelihood on these on these victim models, on these real models that's this cloud APIs providing. And this is just another example. And again, the examples are numerous. Essentially, all these different types of deep learning models, they all have these vulnerabilities that can be very easily attacked. And also, I do want to spend some time actually talk about the privacy issues as well. So as another example, some of our recent work, and also in collaboration with the researchers from Google, have shown that, for example, if you train a language model, like machine translation is one type of language model, but actually For example, if you train a language model that actually given a sequence of words and characters, it can be used to predict the next word and next character, then actually attackers, by just querying this language model, can actually steal sensitive information in the original training data for training this language model. So for example, in one of the case studies, we show that in the training data set that naturally contained uses credit card and social security numbers, attacker, by just querying the learned language model, can actually extract the original social security and the credit card numbers that were embedded, that were in the original training data set. So this is an example showing that in the real world, as we train these large models, they actually do remember a lot. They remember a lot of sensitive information about the training data sets. And hence, we really need to be careful and develop techniques and tools to help improve privacy in these machine learning systems. And there's also some of the technologies that we are developing at Oasis Labs as well, that we call it building a platform for a responsible data economy. As we train these, as we build these machine learning models and machine learning systems, also Mala mentioned that, right, the consumers are actually the products. So really it's about how we can develop the technologies that's needed to help users and data owners to maintain better control of their data, and at the same time to enable data to be utilized in a privacy-preserving way.
Yeah, and I mean, I think we're coming close to time, so we're not going to open up for questions, but I actually want to stay on this point because I think one thing that's come up in all of your comments, even though it's been such a wide range, is this idea of auditability, right? So how do we, I mean, obviously models are going to get more complex, and the more complex they get, adversarial AI is also getting more and more sophisticated, and therefore both on just in terms of security risks and privacy risks, I would imagine someone who is targeting somebody in Kfir's position, or one of the many people making decisions in your organization, one kind of security threat that makes you make the wrong decision could have huge financial implications for the world. So I guess my question is, what are each of you? I mean, maybe this is the question, the last question I can ask you. So I'll swap out what we discussed earlier. But if I can ask you one question, is what do you think you can do in terms of making AI more auditable and more accountable? Because obviously that has great financial value, but also great consumer safety and other kinds of positive externalities. So can I just do a quick round or if anyone wants to jump in on auditability itself?
Maybe if I may start and jump in here. I think from my perspective, if you can leverage kind of a common platform, it'll make your job much easier in terms of audit the models that you deploy, trace every decision, log every decision that you make, so you can really understand what decisions your models make over time, and also watch for something like the data drift. So if the data is now suddenly completely different than what you trained your models on, that's your first warning sign that you may have to retrain your models, that you may have to swap something out. Adversarial effects or attacks are, I think, we're just at the very beginning of seeing that in many systems. As Dawn mentioned, in computer vision, you can fool easily. In translation, you can fool easily. Likewise, we have to watch out for that in many other systems. And it'll be kind of the early days in computers, where we didn't have to worry about any viruses. The more we use AI, the more we have to worry about those attacks in the future. But if you have a common platform, you can audit every decision that you make. You can log things. It'll become much easier, and then trace it back to actually when you deploy and when you build the models ultimately.
I think Professor Song gave a hint towards the future that we want to be, and that has to do with explainable AI. We're not there yet, I wish, but we definitely are working in that direction. For now, we need to be able to respond to, regulators around the world. They are also very sophisticated. They are developing parallel tracks with RegTech in order to be able to do that and to respond with the same type of technologies that we are developing, on the enterprise side. But you start from model tiering, where basically you need to be able to create different tiers of algorithmics. One of the most important things is documentation, as blunt as it sounds. It's just very, very important. Data scientists, they are very good in writing code, but they are not so great in going after that and documenting. And doing that helps a lot. The other thing is to have model validation and independent validators. It's a must into this whole thing. And, in a company dealing with risk like we are, we have several committees that they are going through this till we're bringing things in production. So it's a little bit of via dolorosa that we are inviting it to ourselves in order to be sure that we are open to any kind of regulator from the US, UK, Singapore, that they are, again, becoming more and more sophisticated. They want to understand everything into that. If we're going to get what Professor Song hinted, then we're going to be able to have algorithms of explainable AI in parallel to what we're doing right now. I think that would be optimum for everything, but we are not there yet.
It should be a machine RegTech issue or AI RegTech issue. For example, after we generate a model contains billions of rules, the model cannot be checked by human. We should develop RegTech system to check the billions of rules by machine automatically. We should phase two. We should develop AI RegTech system because our fintech model become complicated. So we should develop a complicated RegTech.
And I think we really need to develop actually essentially new architectures and new types of machine learning models. So in our work and also others' work that have shown is that today's explainability mechanisms themselves actually can be very easily fooled and attacked. Our work has shown that, for example, attention mechanisms and other types of explainability mechanisms, they're actually just as easily being fooled, just like the original the machine learning model and so on. So so what we are seeing is today, even though deep learning models approach has been making great advancements, but they are really learning something that's very different. It's different than what humans learn, and they have these vulnerabilities and issues. And really, we actually need to develop new types of approaches that can be more robust and resilient against these attacks. And some of our work showed that in certain cases, for example, with the network architectures that, for example, have recursion, actually learns recursive neural architectures, then for certain use cases and applications, it actually has better generalization results, and hence you can actually be really, in certain cases, you can have perfect generalization and hence actually be fully resilient against attacks in those specific use cases. And these are just examples.
Dawn Song there, we're just going to jump in as we are up against the clock. Dawn Song there, who is founder and chief executive officer at Oasis Labs, part of the panel there discussing the merits and the limits of artificial intelligence. Malavika Raghavan was the panel moderator. She's advisor and former head of Future Finance Initiative at Dvara Research. And also on the panel there today, Kfir Godrich, BlackRock's global head of technology, Dr. Michael Zeller, head of AI strategy and solution at Temasek, and Wenyuan, who is the founder and CEO of 4Paradigm. And of course, artificial intelligence very much in the news lately. lately, partly on the subject of bias in artificial intelligence and how that can be corrected. But anyone listening to the panel just then would have realized the huge opportunities to grow and innovate when it comes to AI, but also some of the limits. You know, we talked there about regulation and understanding, better understanding. There will be more conversation, I'm sure, around education. But, you know, there is a wide acknowledgement that AI systems can see bias within the system, and the questions remain over what you can do about this, how you can rehash those algorithms that could reward certain groups over others. So lots to talk about. Great panel there. Well, there's much more coming up here on the channel. Stay with us.